Hello, my name is Derek and I'm going to talk to you a little bit about alkaline metals and their chemical reactions. So we're going to have a look at what the metals look like and how they react. We've got lithium, sodium and potassium. They're the first column on your periodic table. We're seeing how they react with oxygen, O2, and water, H2O. First off, I'm going to show you lithium. So this is a metal. I'll show you what it looks like. It's kept in a small pot with the lid kept on because it can't be left in the light and the oxygen, and eventually just disappear. So I'm just going to use the tweezers. You're not supposed to use your hands for it because it can be quite dangerous. Them ones are just a little bit small, so I'm just going to grab some larger ones, make this a bit easier for myself. There we go, much better. So that's the metal, that's what it looks like a black cylinder. It's kept in oil to protect it from the chemical reactions. So I'm just going to chop off a small section and pop that back in the pot where it lives. Make sure you put the lid on and put it away. So it's a very soft metal and very easy to cut off the small section I just did. So I'm going to get that and I'm going to put it into the water container that I've got here. So drop it from quite a height because I'm not sure how it's going to react. You can see that there's a slight buzzing around, there's a little bit of a reaction going on, and it's disappeared completely, it's evaporated. So the pH level in the water has now changed. Alkaline metals have a very specific structure. It has like an outer shell, and that makes it ready to react with whatever it comes into contact with. So lithium has a positive reaction and it's a very easily reactive metal. There has been quite a smell come up from the lithium in the reaction. So now I'm going to move on to sodium. Again, it's kept in a pot the same as the lithium, and I'll use the prongs to get that out. So again, I'll chop off a little piece. I only want to use a small section, and I'll just show you what that looks like. So that's more like a rock-looking shape, and it's in white in colour. So this one should be more reactive compared to the lithium. It has a bigger chemical structure. So I'll pop that into the water, and it's buzzing around straight away quite quickly, far more reactive, and a good bit of steam has evaporated off that. No flame, but sometimes what can happen is you can get an orange bright light on the flame as it buzzes around in the water. That's linked again to the chemical structure and the outer shell. It can have like almost 2 layers of an outer shell, which leads to a bit bigger chemical reaction. So finally we'll move on to potassium, the final one we're going to talk about. Again, the same process, to take it out of the little pot, make sure that I cut off a small piece and then put it back into the pot for safekeeping. You might have noticed a bit of a difference with this one. It's very much darker in colour in the outer shell. But I think that's because it's been put in and out of the pot so many times that it's reacted with the air and the light and not been so protected that it's gone darker in colour. I think this one should have a far greater reaction and also have a flame, but we'll see. So it's buzzing around straight away and quite a big cloud of steam coming off there. Yes, that's definitely a bigger reaction. So again, the chemical structure, it's just got one outer shell and the structure allows it to expand. Alkaline metals are their own group on the periodic table. You've got the columns which are 1 to so on, but you've got columns 1 and 2 which are very much alkaline metals. So as you go further down the columns, the reactions get a lot stronger. There's lots of other alkaline metals that I've just not had a chance to show the reactions to, but they're all equally as important. Thank you very much for watching and carry on with your work. Thank you.